Today we're going to learn something very important called the chain rule. It's a new rule. And after we learn all the other rules, a lot of popular rules and the product rule, quotient rule, power rule, constant, multiple, whatever, we learned so many rules. Now we're going to learn this, the chain rule. What the chain rule says is this. Okay, it says we're going to borrow somebody as our middleman, and then we can do that. So when we take the derivative dy over dx, what it says is going to be dy, we borrow the middleman u, and then du over dx. Okay, so that's the chain rule. I don't know how easy you can tell, but the middleman is, let me give you an example. If I have like y equals 2x plus 1 to the fifth power. In this case, I'm going to treat this as my u. So my u equals 2x plus 1. So y equals u to the fifth, and u equals 2x plus 1. So dy over d, you take the derivative with respect to u. So the dy over du will be 5u to the fourth, isn't it? And then du over dx, that will be 2. Okay, and then we multiply these two together. So my dy over dx by chain rule, which is dy over du times du over dx. Now see, my dy over du is 5u to the fourth, and then du over dx is 2. So that should be 10u to the fourth. However, because I'm looking for dy over dx, so I shouldn't have u here, but I know u. So that's 10 times 2x plus 1 to the fourth. Okay, so this is how we worked with the chain rule. Of course, you don't want to expand this, right? To the fifth power, when you expand that, you get so many terms. At the end, even you combine like terms, you should have 6 terms. And this one has like 5 terms. So when you take the derivative of that y, then you get 5 terms. That sounds right, but you don't want to go to the hassle of so many distributive properties being used. And we use this chain rule, make it much, much easier to get the answer. Now you probably see that the key here is to find u, is to find who is the middleman you're going to use. So that's a u. Once you get used to it, once you did some exercise and get familiar with this, you don't really need to write this out. But at the beginning, if you want, you can write it out. When you put a u as that 2x plus 1, 2x plus 1, you can treat this as one letter, right? It's an invisible u here. So when you take y prime, so you bring the 5 here, and you have this guy to the fourth, and then you multiply by, you take a derivative of this invisible u to x, so du over dx, then you get a 2 at the end. So you have a 10, and then this 2x plus 1 to the fourth power. You can also get that easily if you want. Okay, so let me give you another example. If I said y equals, let me give you y equals 5x to the third. I will try either way, okay? So the first one, I probably want to write that as 125x cubed. So the y prime will be 125 times 3x squared. So that will be 375x squared. You can do that. Or you can use u, let u equals 5x. My y equals u to the third. So dy over du should be 3u squared. And then du over dx is 5. Okay, so dy over dx is dy over du times du over dx. So that's a 3u squared times 5, which is a 15u squared. And what is u? U is 5x. So we bring this back. So I got 15 times 5x squared. So I get 5 times 5, which is 25. 25 times 15 is 375, and then x squared. See, you should have exactly the same answer, but this one is, if you have something, you can easily just write that into a simpler expression. You probably don't really need you don't really need the chain rule, but if you use the chain rule, you get the same answer. But for this one, if you have something like to this power, like a 5 or something like a weird, it's not as easy as this, then you will need that. Let me give you another example here. Y equals, okay, so two methods, or I can just use the chain rule. Okay, so what about that is x plus 1 to negative 1/2. Or it could be given like this. Okay, can you take the derivative? So in this case, we're looking for dy over dx, but I can borrow a u as my middleman to make my life easier, so I can use the chain rule. So my u will be x plus 1. So y will be u to negative 1/2. And the dy over du, we take the derivative of that, will be, we use these the power rule, so it's a negative 1/2, and then u to negative 1/2 minus 1, so it's negative 3 over 2. And the du over dx, du over dx is just 1, because if you take a derivative for x, then that's just that. So my dy over dx will be dy. You don't have to write this in the future because you're already, once you're very, very familiar with this chain rule, you don't have to. But I usually I like to write that at the very beginning. So it's 1/2 and u negative 3/2 times 1. Okay, so that is negative. That's 2 in the denominator, and then the u here is a 3 over 2. It's like this, right? But I have to change that to be u as that. So I get a negative 1 over 2 x plus 1, and then to the third, and then take square root. And then once this power is more than 2, so I can bring that into 2 and 1. I leave 1 inside, the 2 goes out. So I get a negative 1 over 2 times x plus 1, and then square root of x plus 1. Okay. Of course, if you want, you can multiply by the square root to get a square. You can do this, square root of x plus 1, and then you have twice of that in the denominator. Either way, okay, as long as you get that similar, either this way, because sometimes the book said this is better, sometimes they don't like the square root in the denominator. You have to write that in this way. Okay, so that's another example to use the chain rule. I hope that you get a little bit more familiar so you can see how interesting it is, right? Okay, so next example, y equals 5x plus 1 and x to the third plus 5x. You think, hey, I use quotient rule, not yet. Okay, to the fifth. You don't want to get a 5x plus 1 to the fifth, expand that, and then you get an x cubed plus 5x to the fifth, expand the denominator. Then you have the huge numerator and a big denominator, and then you go ahead and use the quotient rule. You don't want to do that. So I'm going to borrow a friend. I'm going to bring in a friend. U will be 5x plus 1 over x to the third plus 5x. Okay, so my y will be just u to the fifth. The easy way is dy over du is just 5u fourth, isn't it? That's a sweet. And then if we want to get a du over dx, so we take the derivative of this one. And then do you remember that f over g quotient rule prime equals, the denominator is g squared, and then f prime g minus f g prime, right? So that becomes, the denominator is x to the third plus 5x squared, and the numerator prime, which is 5. And then I copy the denominator. I multiply by that. minus, I copy the numerator, and then I take the derivative of the denominator, which should be 3x squared plus 5. Okay, see, you have done a lot of exercises, so what I'm saying here makes perfect sense to you, right? Okay, so I got x to the third plus 5x squared, denominator, and the numerator, I'm going to do several distributions to simplify. So I get a 5x to the third plus 25x, okay? Then I'm going to minus this. For you, there should be 4 terms, and all of them so far looks like they're positive, but I have a negative sign, so I'm going to have all negatives, okay? The first one, 5x times that, I get 15x to the third. Outer, so I get a 25x, okay? Inner, I get a negative 3x squared. I skipped one step. I just distribute this x directly into all the 4 terms. Okay. All right. So the numerator, I get a negative 10x to the third minus 3x squared, and then plus minus 25x, that is gone, so minus 5. And here x cubed plus 5x squared. All right, now I get dy over du and du over dx, so I can do dy over dx. That's what we're looking for, right? So that would be dy over du multiplied by du over dx. dy over du is 5 u to the fourth, okay, and this is x to the third plus 5x squared, and then the numerator is negative 10x cubed minus 3x squared minus 5. Now this u, I cannot have the u here, and the u is this guy. Okay, so u is that. Then that will be 5 times 5x plus 1 to the fourth and x cubed plus 5x to the fourth. Okay, see, that's 5u to the fourth. Okay, so that's u. And then I'm going to multiply by x to the third plus 5x squared. And then I pull the negative out because I don't really like that. Positive 10x, positive 10x cubed plus 3x squared plus 5. Okay, so my answer, my final answer is a negative 5 times 5x plus 1 to the fourth times 10x cubed plus 3x squared plus 5 divided by x cubed plus 5x. Okay, so I have a 4 here, I have 2 here, so I get a 6 power. Okay, so that is your answer. So what do you think? By using the chain rule, you make your life much easier because you just simply get a u, and then you work with, pretty much you just work on this first, right? du over dx to get that. Okay, so that is another example to show you how easy it is if you use the chain rule to solve the problem. Okay, so let me work on another one. Y equals cosine x to the fifth plus x. All right. Well, we don't really know. I know what is a cosine x. To take the derivative, I get a negative sign. So let's use u equals x to the fifth plus x. So my y will be cosine u, and my u is x to the fifth plus x. Isn't it? So y dy versus du, dy over du, that would be negative sign u, and the du over dx, okay, that would be 5x to the fourth plus 1. All right, next, I'm going to multiply this too, so I can get a dy over dx. I think I can skip, next time I'm going to skip this step, okay, du over dx, because I already know that, I just need to multiply them. So I get a negative sign u versus times 5x to the fourth plus 1. And the u is x to the fifth plus x. I just need to substitute here. So my answer is negative. I write 5x to the fourth plus 1, and then sine u, which is x to the fifth, plus x. Okay. It looks very complicated, but once we have the chain rule, we bring the chain rule here, so you can see that it's much, much easier. All right, now let's go back to what we need to do. If you try to find the derivative of a function, and you don't know how to do that, but you know something, you can use a letter to represent, like the middleman, to represent a part of that, and then make your life easier. For this one, your u, you can use this, a u, then you can get a y equals to cosine u, and then u will be x to the fifth plus x. And then you do dy over du, then du over dx, then you multiply them. Did you see the chain works? Okay, so that's the chain rule. I will give you a lot more example here. Next one, y equals sine 5x. All right, now if I have a question like this, my u will be 5x. How is that? So y will be sine u, and u is 5x. So dy over du will be sine prime is cosine u. And then du over dx, which is 5. So dy over dx, remember I said I'm not going to write down this step because I just multiply. So I get a 5 cosine u, but u is 5x. So I write 5 cosine 5u. Okay, so to this question, I'm still writing down what is u, and to let you see the step by step. But eventually, if you already know this, you know very, very well, you don't need to. So what you're going to do is just, sine of something, so sine prime, that's cosine. But this is not just a simple x, it's a 5, right? So that's going to be the derivative of that. So you get that directly. So later you can, later you should be able to do this very quickly. But if you, as the practice stage, I still prefer you to write that. Okay, so next one. Is y equals 5 cosine 2x minus pi. So you know what is u, right? So u is 2x minus pi, and so y is 5 cosine u, and u is 2x minus pi. So dy over du, that is negative 5 sine u. You agree? Yeah. And then u du over dx is just 2 because the pi is actually a constant. So when you multiply this together, dy over dx will be 2 and 5, so you get a negative 10 sine, and then u, I just write 2x minus pi. See, I skip more and more steps, but this is how you get the answer. So I think that's about everything that I would like to do. Those example. The other thing, let me see. Okay, this. If you have like y equals u to the n, u of x to the nth power, then the dy over dx will be n times u to the x, and then the power minus 1, then du over dx, right? So this is what we did earlier, and this is called the general power rule. So you're not only just bring this n to front and reduce the power here by 1, and also take the derivative of that, du over dx, and to write that at the end. So that was, I think this one you can just do this by the chain rule. It's not really hard. Let me see what else. I think that's about it. We have done so much, and then the chain rule again, I think it's about the last one we're going to learn for all those rules. And I strongly suggest you work on the question sum practice to see you get used to this chain rule. The chain rule is very easy to explain. And also, if you write this down, like u equals something, and rewrite your function as a function of u, and then if you do this step by step, I think after you work on like 5 or 10 questions, you probably will be very good at that, and then you don't really need to worry about all the steps. So that's the chain rule.